All right, so let's talk about attention now, which is one of the basic core problems in cognitive psychology. One of the ways you can think of attention, one of the ways you can view attention is as an information filter. So attention works essentially to filter out irrelevant things, irrelevant stimuli that are coming in from your environment, so that the only things of your environment that are left in your consciousness are the things that you choose to pay attention to. So one of the reasons you have to have this filter to filter out irrelevant stuff is because our attention is limited by the amount of information we can focus on at a particular time. Our attention is limited. So for example, if you think you're a great multitasker, you're wrong. You're not. Most people are not good multitaskers. As a matter of fact, most of the data shows that, people who think they're good multitaskers are actually just doing a whole bunch of things poorly. So, that just, some evidence there about how limited our attention is. There is a bottleneck in our processing that filters out everything except the information we're attending to, which of course is good and bad. You do want to have a filter to focus the things you need to pay attention to. But of course, if you're not paying attention to other things, you will, you will miss stuff. The filter acts as an early processor of the information. So the filter, in other words, the filter comes in early in the process of information processing. And it only lets in what is relevant to a particular task or focus. There's been a lot of support for this view of attention over the years. One of the bits of support is in research using a shadow task. So in this particular type of experimental paradigm, participants are asked to repeat a message played over headphones to one ear, while a competing message is played in the other ear. The subjects have to focus their attention on the target message that they've been asked to repeat. And of course, if I stick if I pop a pair of stereo headphones on your ears and I feed one message in, one series of statements in one ear and another series of statements to another ear, and then I ask you, okay, I want you to repeat everything you hear or write down everything you hear out of the left ear. So you're going to do that. And of course, you're going to be able to do that perfectly well. However, if I then ask you what was going on in the right ear, you're not going to know. And this is what we see with subjects, is that they often cannot accurately report the content of the competing message. However, there is this little strange effect called the cocktail party effect, which is kind of an old school term because nobody has cocktail parties anymore. But if you've ever noticed that, you can be in a loud, crowded place with lots of people saying lots of different things, but if somebody says your name, you're able to hear that over the loud noises at a party or at a place. So we do have this filter that is tuned to things that are specifically relevant to us, like our names. When you put together the results of the shadow task studies with the cocktail party effect, you get some different modified views of this attentional filter. So Treisman suggested a modified filter model. So there's in Treisman's view, there's an early process partial filter that allows some information to pass through, but only after it's been attenuated. So after it's been sort of like knocked down a few notches. Some of the information is being passed through the filter, but at a lower volume than the most relevant information. So essentially what's going on is you've got your attention focused on some bit of conversation or whatever. You're reading something, but but there is an early filter that does allow some other information other than what you're focusing on pass through, but it turns down the volume. It turns down the salience of that particular stimuli, and it lets it pass through. And it's just enough to where you can sort of like pay attention to something other than what you're focusing on. If you think about it, it makes a lot of sense from an evolutionary perspective, right? You don't want your attention to be entirely, 100% on, whatever it is you happen to be reading or looking at. You've got to be, you've got to have a little bit of attention, paying attention to what's going on around you. So like, think of that cat, that's stalking through the grass and hunting a bird. Those cats can be distracted. So 100% of their attention is not focused on that bird, even though it's a very important survival thing that they're doing, hunting. They can still be distracted by other sounds. So they are focusing a little bit of their attention on something other than that bird, and we probably do very much the same thing. Another view of attention has attention as a limited resource, which is very true. Attention is a very limited resource. We only have a certain amount of attention to give at any given time. So one of my favorite views of attention, one of my personal favorite views of attention, is attention as a spotlight. So if you think about this dark room or dark scene, and what attention is, it's a spotlight that goes around and focuses on specific things, and whatever that specific thing the spotlight is focused on, that's what's in your current attention. So attention is this spotlight for our consciousness that's focused on some aspect of the environment that currently has our attention. And of course, like any other spotlight, this attention spotlight can be moved around the environment as our attention shifts around to different things. Kind of related to this is another view, another resource-based view of attention, and that's attention as mental capacity. Attention has a limited capacity due to the limited amount of cognitive resources available for a task. If you think about it, paying attention, it's work. You got to work. How well do you pay attention when you're extremely tired and hungry? Not very well, which suggests that the act of paying attention, the process of paying attention, is something that's very resource intensive. Attention depends on the amount of mental effort that's required for a particular task in relation to the cognitive resources currently available. So you have to have a certain amount of mental effort available in order to pay attention. Over time, as described in your book, later capacity models that were developed by researchers focused more on how interference from multiple tasks can tax attentional resources and cause decreased performance on one or both tasks. So essentially, and this goes back to what I said earlier about being a multitasker, which some people claim to be excellent multitaskers, but you're not, because these capacity model theorists have talked about how the more tasks you have to focus on, the more resources you're drawing, and ultimately you're decreasing your performance on all the tasks that you're trying to multitask on. Daniel Kahneman proposed that attention is a limited cognitive resource. Okay, so no kidding, right? That can be allocated to different tasks based on our intention. So behind this focusing of attention is intention, intent. What do you want to do? Tasks that are more difficult than others require more attention, and we allocate more attention to those tasks. So, if you're sitting there reading, if you're sitting there watching a movie, let's say you're watching a movie that you've seen 100 times, right? We all have those movies that we like to pop in every now and then, right? But one of the reasons we probably like to do that is because the movie that is on, it's something we like, but it's something we don't have to pay a lot of attention to. We know it's going to happen, and we can enjoy it without burning a lot of energy or resources in paying attention to it. That's one type of task, and compare that with another type of task. Let's say, for example, studying a very difficult topic. That's going to be a very task that requires a lot more attention, and we're going to have to allocate a lot more attention to that task, hence a lot more resources. This also suggests all this focus on resources also suggests that arousal can influence our mental resource capacity. So general arousal levels, that is arousal defined as, being more energized and being more activated, can affect our mental resource capacity, which is probably true, right? One of the treatments for attention deficit disorder. And of course, attention deficit disorder is very controversial. I personally don't believe it really exists, but some other people do. But it's this condition where kids, mostly boys, are unable to sit still and pay attention at school, so they're diagnosed with this attention deficit disorder. And the standard treatment for a long time for attention deficit and hyperactivity disorder has been drugs such as Ritalin. And, when a lot of people think that Ritalin is a downer, it's like something that kind of calms you down, right? So that you can pay attention, when in fact, it's the exact opposite. Ritalin is actually a stimulant. Ritalin is an amphetamine. It stimulates, so it raises arousal. And that leads usually to an increase in attentional capacity. So there's some evidence there about the link between attention and arousal. Some of the studies that have looked at this attention as a resource use a paradigm called the dual task method, which is described in your book. In the dual task method, subjects are asked to complete two tasks at the same time, to compare with performance on these tasks when they're performed alone. So first, I say, okay, I'm going to give you two tasks, and you have to do these two tasks at the same time. And it might be, write a paragraph to do this, and memorize this thing, right? Memorize something, memorize a list of words. And of course, when we ask people to do these two things at the same time, they fail miserably at them. But then when we go back and ask them to do them one at a time, they do quite well. They do much better, I should say, than they do in the dual task. Another view that is less known about attention, but that is extremely interesting, is, so we've looked at attention as a limited resource and attention as a filter, right? We've talked about those two. But a third view of attention, which is really interesting, that's described in your book, is attention as a feature binder. A feature binder. And this basically is based on looking specifically at the processing of information as separate stages. And when you separate out the stages of processing, you're able to focus your attention a lot better because you've sort of broken down the work into several separate stages. So, for example, during the first stage of information processing, there is automatic identification and processing of the features within a scene of an environment. So you're not aware of the identification of these features, okay? We talked about this in the previous video, where we do a lot of things automatically, and this is an example of that with regard to attention. And And so what this view is suggesting is that during the first stage of information processing, the features that we're processing in the particular environment or the scene that we're looking at, it's done automatically. We don't have to sit there and concentrate and look and say, that is a Kleenex box, that is a cup, that is a chair. We don't have to sit there and name everything. It's just done automatically. We're not aware of the identification of those features. It is something that is done automatically, unconsciously. The first stage, this information that is generated during the unconscious automatic processing in the first stage is then passed into the second stage. The second stage involves consciousness. It involves conscious focused attention to combine the features of the scene. And then once you get the features of the scene all pieced together, it allows you to understand and think about what you're focused on, what you're looking at. The attention is the glue that holds together the features of the objects together. So essentially what this view is saying is that, processing information in a particular scene, you have these objects that are sort of just like in the first stage coming unconsciously, being identified unconsciously, and then being passed into the second stage. And in the second stage, it's where we actually take all of that stuff that we've seen both consciously and unconsciously and glue it together and give it meaning as we focus attention to it, as we focus our attention on it. One of the really cool things about this attention as a feature binder, I focus my attention on a particular thing in a scene, and that attention allows me to give meaning to that particular spot and inform me as to what the things are that I'm looking at. One of the really neat aspects of this view is that there's some brain activity that is associated with a first stage of unconscious identification and a second stage of focused attention to combine the features. That's really neat that we've actually got some neurological and neuroscientific data that suggests that this view of attention might make some sense. So how does attention affect our perceptions? Well, there are some additional effects of attention. For example, one of the things that attention helps us do is to detect changes in the environment. So, if you're just sitting there chilling and all of a sudden, a very unusual looking person walks into the room, you're going to focus your attention on that. Attentional boosts to performance attentional boosts to performance based on congruencies between targets and responses. So in other words, attention helps us to focus on the common things that exist between the things that we're looking at and the things that we want to do. So, for example, if I want to pick up a cup, well, I got to focus my attention on that cup. I got to look at that cup and see what kind of cup it is. If it's a coffee cup, it'll have a handle. And I'm going to pick up that I'm going to be very, careful about how I reach over, grab that coffee cup and pick it up, especially if it's full. And if it's full, well, I better be paying attention and seeing that it's full. If it's empty, well, I better be paying attention to that and not try to take a drink out of it. So attention is going to definitely affect the way we perceive objects, the way we perceive the objects that we want to interact with. One of the problems with attention, I guess, one of the issues, I guess, with the fact that we have such limited attention and, we use attention to focus our perceptions, is this thing called inattentional blindness. And this is our inability to notice a major change in our environment because our attention is focused on other aspects of the environment. Magicians make a living off of this, right? A good magician is going to be directing your attention to one spot in the scene that you're looking at while they do something in another spot, and to make it look like it's magic. So magicians are experts at taking advantage of this inattentional blindness. This is a big problem when you're driving. If you're focusing all of your attention down one side of the road, and then you decide to execute a left turn and you didn't see the car coming from the other side because you were not paying attention. It's really tough for us to deal with that. It's something that you have to be very much aware of when you're doing things like driving, because, your brain, as I mentioned earlier in the previous lecture, your brain is going to be filling in the blanks for what it thinks is happening. And if you happen to be driving and you're about to execute a turn, your brain is, if your brain hasn't really perceived a car coming the other way, it's going to tell you there's no car there unless you focus your attention down that street and look at the car coming that's about to get into the lane, that's about to come down into the lane where you're going to cut across. So, inattentional blindness is something that's a very real thing. We deal with it constantly. And it is one of the side effects of our attentional system. One of the really interesting phenomenon associated with attention is the fact that incompatibilities, things that don't really look like they go well together, really tax our attention. If we see something that is like incompatible or doesn't really belong where it's supposed to be, we actually will spend more time paying attention to that to try to figure out what's going on. And this is demonstrated in your book when we talk about the Simon effect, right? It's a really simple example, right? So basically you're being asked to look at different shapes that appear on a small screen in front of you. And you're asked to, and you're being asked to determine if the object that you see is either a rectangle or a square. And you've got one button that says rectangle on the left and the other button that says square on the right. So if you see a rectangle, you punch the rectangle button. If you see the square button, you punch the square button. And it's funny because if the rectangle shows up above the rectangle button, we tend to push that button a lot quicker than if the rectangle shows up above the square button on the other side. There's that incongruency. There's like, wait a minute, that's a rectangle, but right beneath it is the square button. I have to think about going over to the other side, and making sure I press the right button. One of the mechanisms that's been sort of speculated to underlie the Simon effect is the attentional movement hypothesis. And this what the attentional movement hypothesis is it says that the shift in attention that you have to do to a target on the left or right of your attentional focus biases you to want to respond on the side of the attention shift. A response from the other side of the target must overcome this bias. So if you see that square on the left side, you automatically, and if it's being presented either on the left or the right, and you see the square on the left, you have a bias to want to respond on the left side. Similarly, if you see a rectangle on the right side, you have a bias to want to respond on the right side. If that's switched, if the rectangle pops up and it pops up on your right side, but the button's over on the left, that responding to that target is going to require extra time, extra attention and extra time. The other mechanism that's been speculated to underlie the Simon effect says that this bias in responding, this bias of responding faster when they're on the same side, it's due to a correspondence to an object of reference in the scene rather than the current focus of attention. So in other words, basically what it's saying is that over on the right-hand side, if you get the rectangle popping up, and then you got the rectangle button there on the right-hand side, it's not really an attention mechanism that's causing you to speed up. What it is, it's an object reference. In other words, you're matching objects. You've got a rectangle target and another rectangle next to the button. You're able to more quickly do that. When you don't have that, when the rectangle appears on the right side of the screen, but the button's on the left side of the screen, you no longer have that object reference. You're no longer simply matching objects. So you just got to spend more time scanning the scene and looking for the matching object. So it's not quite attention. It has more to do with our ability to perceive and match similar objects, which is different than attention. One of the more famous ways of studying the effects of automatic processes on attention is the famous Stroop task. And this is essentially the task that measures your ability to inhibit your automatic processes and focus attention on a conflicting task. So all of you that have taken experimental psychology in the experimental lab know about the Stroop task. I think it's used in the experimental lab. But essentially what this is it's a task where you're asked to read the color of words. So for example, you've got a word that you've got the word BLUE written on the screen. And then you've got the word RED written on the screen. So if I just ask you to read the words, blue, red, you don't do so bad at that. But then if I ask you to read the color of the words, so if I print the words in different color fonts, and then I just ask you to name the colors of the font of each word that's printed, for the word blue, if it's printed in blue font, you're not going to have any problem with that. You're going to say blue. But if I print the word blue in red, it's going to take you a little bit more time to look at that and say, you're going to go, red. So if you have you focus on the color, and that's what the Stroop task is. That basically is this conflicting or incongruent information. Essentially requires more attention. This conflicting information requires more attention. One of the neat things about the Stroop task is that you can get better at it, actually. With practice, the subjects can get better. In other words, they will get faster at naming colors. So one of the issues in studying attention has to do with this distinction, this dichotomy, I guess, between automatic processing, this sort of automatic unconscious processing that we probably do, and controlled processing, the processing of information that we consciously control and focus. Understanding how those two work together is one of the big challenges of cognitive psychology. Tasks that are automatic don't require much attention, and they don't tax our cognitive resources. So researchers are interested in, well, how does a process become automatic? How does a process become automatic so that it doesn't have to tax your resources anymore? Well, one of the factors that seems to go into making processes automatic is, as you've probably guessed, practice. Practice seems to be a factor. So constant exposure, constant attempts to deal with for example, something that's incongruent or something that you're doing, helps you to ultimately make something that you had to focus a lot of attention on much easier. For example, I can give you an example. For most of you right now, you're undergraduate psychology students. Reading a psychology research paper is probably pretty taxing. It's pretty tough. You have to, you're like, oh geez, you have to sit there and you're like, well, he told me to look for the IVs and the DVs and, I got to do that. And then, I got to figure out, well, what does this study mean? So, you're spending a lot of time doing that. But that is a skill. Reading research papers is a skill, and with enough practice, you're going to get to a point. If you keep doing it, and let's say you go to graduate school in psychology, you're going to be reading a lot of research papers. Eventually, you're going to get to the point where you can read research papers almost automatically, almost like you read like a novel. Another example that all of you have probably faced is driving. Remember how tough it was when you were first driving? How, making sure your left turns were okay, and, making sure that you were going the right speed limit, and, you couldn't really do anything else except drive, right? And you're not supposed to, obviously. Driving was very taxing when you were a young, new 16, 17-year-old driver. But now, now that you've been driving for a few years, it's automatic. You don't really have to think about it anymore. You're flying through traffic and eating and looking at your phone, and it's no big deal anymore. So practice does seem to be a factor. Schneider and Shiffrin, two very, very famous, well-known cognitive psychologists, have defined an automatic process as one that is initiated from a specific output, either internal or external, and activated without control or attention. So it's an automatic process that's initiated from a specific output, either from inside your mind or in the external world, and it gets activated without any sort of control or attention on your part. By the same token, controlled processes, in Schneider and Shiffrin's view, are activated based on one's intentions and require attentional resources. So it's it's a pretty straightforward distinction between automatic processes and controlled processes. And it turns out that experiments support the use of both controlled and automatic processing in attention tasks. One example of a task that comes from the outside that you do not really have to, spend any time paying attention to is identifying letters. Not necessarily reading them, but perceiving the letters. Perceiving letters is automatic. If you've ever noticed, you can't not read something. If there's some pattern on a wall or on a paper that kind of looks like a letter, like letters of the alphabet, you're going to perceive them. It's our perception of letters is a very automatic process. We will see letters even when there aren't any letters there. If a clump of rocks or something comes up, we will perceive it. Faces, we also see faces too. Faces are something that we automatically process. We don't have to think about it. We will automatically see faces. And of course, sometimes we see faces where we shouldn't, like, on the front of cars, right? Cars have faces. Maybe an image of Jesus on a tortilla, right? You shouldn't have seen that face there, but it's there. So we do have a lot of these automatic processes where you do not, that they're just automatically activated without any sort of control or attention on your part. And this is what Schneider and Schifrin would define as an automatic process, whereas their controlled processes are ones that are activated based on your intention. So once you see that clump of letters on the page, you focus your attention on it so you can start putting together what the words mean. And that requires attentional resources. Another researcher that's mentioned in your text, Logan, according to Logan's theory, automated processing, the automaticity, which I don't even think that's a word, but whatever. Automated processing occurs through the encoding and retrieval of multiple experiences with a task. So constant experiences with a particular task, like driving, for example. You're going to go through a lot of stages of encoding the information that you're processing and then retrieving that information as you need it. Controlled attention is required initially for the encoding and retrieval of information about the task in memory. So you do have to focus and remember, for example, what to do, which lane to be in when you want to make an exit, how fast to go, how to turn the wheel when you want to execute a left turn in that particular weird intersection. That attention is required when you're encoding and then retrieving the information early on. But again, as you go through the constant process of encoding and retrieving, ultimately that becomes automatic to where the encoding and retrieval no longer requires your focused attention.